Okay, hello guys. We are starting our second lesson in GCSE chemistry. Last time we kind of looked about the elements, the periodic table, and atoms. So I thought that we dive into periodic table in our next few lessons. Now we are looking at group 1, which what the elements are here. With lithium, sodium, potassium, rubidium, caesium, and francium. I'd like to apologize about our slow update. So, it's been a month since our last update, but I promise you that we'll have 1 or 2 updates this month. Okay, let's get started. So, these are the elements: lithium, sodium, potassium, rubidium, caesium, francium, with their atomic numbers respective of 3, 11, 19, 37, 55, and 87. And you might know lithium from lithium batteries, sodium from table salt, or potassium from lots of nuts and stuff. But you might not know rubidium, caesium, and francium, and that's fine, because today we're going to talk about them. When you see the term alkali metals, you might think of maybe tin, or gold, or silver, or something like that. These are hard, they have a high melting point, like gold, its melting point is like 8,000 degrees maybe, and they also have a high density, like tin or lead. However, alkali metals are like just the opposite. They have low melting points. They are soft, that you can even cut them apart with a knife, and they have very low densities. Furthermore, they are very reactive to other elements, especially oxygen, chlorine, and water. So let's go to look at some properties and let's take some notes. So they are soft, they have low melting points, and they have low densities. And they're very reactive. Okay, so we have something we need to know is that as we go down the group from lithium all the way down to francium, the first thing is that they get more reactive, and we'll explain that later. If you put sodium or lithium in water, what it'll do is just get some bubbles out, release some energy, and that stuff. But if you put potassium or rubidium in, they will actually cause sparks. And if you put francium in water, well, don't try this at home, it will cause a huge explosion. Which you don't want. The second thing is that the melting points and the boiling points decrease as you go down the group. Maybe it will take like 50 or 90 degrees to melt potassium, for example, but it only needs room temperature to melt francium, which you can think. If you put sodium with chlorine, that's table salt, if you sprinkle table salt on your food, it won't just go on fire. But if you put francium with chlorine, which makes francium chloride, and you sprinkle it on your food, and probably there'll be an explosion. So this is what you need to know. The big question is, why are these alkali metals so reactive? And because we don't have much space, I'm just gonna make this smaller. Wait. What we might want to ask is, why do alkali metals are so reactive? Like, we know sodium chloride, and so why do they react so much? So alkali metals, what I haven't covered last time actually, and we'll do that sometime later, is that they have shells. So like, if this is an atom, and I'm not drawing the nucleus, let's just say this is the nucleus, and there are a lot of electrons going around it, like that. The shells are actually 2, 8, 8, 2, 10. So the first shell can only have 2 atoms. The second electrons. The second shell can only have 8 electrons, the third only 8, fourth 2, and the fifth 10. The reasons will be in our video about shells later on. If you notice about group 1, lithium has only one shell on the outer end, and this is a lithium atom. However, if you take a sodium atom, I can't draw too much, but this will do. A sodium atom, you can see that it also has one electron on the outer shell. And the thing about elements are they want a complete shell, like what sodium wants. And I'll draw this in like yellow, is that there will be, there will be like so many electrons on the outer shell, and then there will be a full shell, and that's what it wants. However, the problem is that it can't gain so much electrons, thus it must like combine with other elements to do so. This is ionic bonding. Take chlorine for example. Chlorine's atomic number is 17. So if you draw it out in the electronic configuration, what you get is this. So what you get is 2 in the middle, 8 on the second shell, and 7 on the last shell. And this is, chlorine doesn't want this, because chlorine wants a full shell. And what you're giving them is 1 electron less than the full shell, and that's chlorine atom. As a chlorine atom. And what you do with sodium is that it transfers this atom, this electron, to the chlorine atom. And then chlorine gets a full shell. And this becomes Cl minus because it has a negative charge. This becomes Na plus, and they kind of combine to make NaCl, which is table salt. This is ionic bonding. So the big thing about ionic bonding is that any element can bond with another element if they can make a full shell. You can't bond oxygen with hydrogen well with ionic bonding because they don't complete a full shell. So that's the thing. However, NaCl can, and all the halogen group in like fluorine, chlorine, etc., they can bond with the alkali metals using what we just said. Okay, have you got it? Please pause the video if you want to take some notes, etc. And I'll just make this smaller. Sorry, because not really good. We don't have much space here, so well. Okay, everybody done? So let's continue. So actually, any two elements can do it, but what makes alkali metals so reactive is that they only have one electron on the outer shell. And this makes it easier because the pull from the nucleus to the outer shell electron will be smaller as you get out. So that's the good thing, because it will be easier, and that's why it's so reactive, because then there's a boom and the electron gets out, and then boom, they get together, and boom, a new element is formed. That's how sodium chlorine forms, and so things like that. Why do they get more reactive when they go down? Because if you draw like draw Francium, I won't draw it because it has 87 electrons and we'll never get to the end of the lesson without me finishing it. But I'll just do this. So many shells. And then the last shell where we have 1 electron. We know that. Thank you. Thanks for the periodic table. We only have 1 shell. And then the francium. So this bond from the nucleus to the electron will be weaker. Let me draw it in a color we can see. Weaker. Because it's farther away. And that's the same for like gravitational pull from our sun to Earth. If there was a huge planet very far away from the sun, maybe light years away from the sun, it will still get pulled in an orbit, but the pull is weaker, and the Alpha Centauri system does not get into our sun, mainly because it's bigger. But even if it was smaller, it's so far away, it doesn't get into orbit. So that's the thing. The outer electron has a weaker. The nucleus has a weaker pull on the outer electron. So something like francium could easily get combined in ionic bonding with a halogen element, and then they boom and will become a compound, like from last class. So what can alkali metals bond with? And that's our next topic. And please take notes because I'm going to make this stuff smaller. Wait a sec. Okay, it's getting smaller. So, well, let's go. So firstly, it can bond with chlorine. I said that it can bond with nearly anything from the halogen group, but to make it safe, I'd say mostly chlorine. Lithium can bond with chlorine, sodium can bond with chlorine, potassium can bond with chlorine, and that's the thing. The most famous bonding with chlorine is sodium chloride, which is NaCl, and that's table salt. However, it is important to know that any alkali metal bonding with chloride forms a salt. So any alkali plus chlorine equals a salt. And it's kind of like the white substance you get. But their properties differ. Like francium chloride will catch on fire when you sprinkle it on your food, and that's true. And nearly only sodium chloride is edible, or very safe to be edible, to be honest. And also, it can bond with H2O, which is water. And what it does is that it becomes an alkali hydroxide. It becomes an alkali hydroxide plus hydrogen. For example, 2Na plus 2Na plus 2H2O, and what you get is NaOH plus H2. Lastly, it can also bond with oxygen, like alkali metals can also bond with oxygen. And what it does is that there are different types of bonding with oxygen. Firstly, it can become an alkali oxide. For example, lithium plus oxygen will become Li2O, which is lithium oxide. But potassium plus oxygen can have two ways. Firstly, it will become KO2, which is potassium peroxide. And it can also become K2O2, which is potassium superoxide. But, well, you don't need to learn that for GCSEs. You don't also need to know how they form. Just know that they can become superoxide, peroxides, or oxides. And well, that's all you need to know for this lesson. Thank you for listening. I'll send you the notes and see you next time.